Hello students, today we're starting a unit on momentum. Whenever you hear the word momentum, you might think of something that is moving, right? Something that might be hard to stop if you try to just get in the way of it. That is a good description of what momentum is in physics, because momentum in physics is just a quantity for how much motion something has. Okay, the equation that we use for momentum is this. We use a lowercase p to notate momentum, and it's equal to mass times velocity. Okay, these two things multiplied together might ring some bells from the last unit of energy, and that's because kinetic energy was this equation. Alright, you might be wondering, why do we need both momentum and kinetic energy to describe something with motion? If both of them have mass and velocity multiplied to each other, why do we need both? Okay, well, momentum and kinetic energy are different things. We use them to calculate different things as well. Momentum is a vector, so it has a direction, and kinetic energy is a scalar, so it doesn't have a direction. Okay, we're going to revisit how these things are related in the future, but for now, let's just do an example of how to calculate momentum. Okay, here I drew out a person pushing a box of mass 12 kilograms and a velocity of 3 meters per second. If I wanted to calculate momentum, all I would have to do is just multiply those two numbers. Okay, so this is 12 times 3, which I know is 36. Alright, in the unit for momentum, there's not any special unit for it. We just have to combine kilograms and meters per second. So the unit is going to look like this. Kilogram meter per second. This momentum equation is a fairly easy equation to work with. I'm going to show you a trick that you can use to solve for the other variables in a very simple system. Here I've drawn a triangle with the variables momentum on top and mass and velocity on the bottom. You might already be familiar with how to use these kinds of triangles to solve for the variables within, but if not, let me explain. Whatever variable I want to solve for, I have to cover that variable up. And so let's say I want to solve for momentum. I would cover that up, and then if the two remaining variables are across from each other, then you multiply. Or if the two remaining variables are above and below, then you would divide. So in the case of momentum, mass and velocity are across from each other, so it's mass times velocity is equal to momentum. If I wanted to solve for mass, I would cover that up, and the two remaining variables are momentum divided by velocity. So I know mass is equal to momentum divided by velocity. If I cover up velocity, then my two remaining variables are going to be momentum divided by mass. Okay, so that's how you can use this triangle to solve for all the variables in that equation. Okay, hope that helps you get through the Google form for today. Tomorrow we're going to continue with momentum, and we're going to introduce a new term called impulse. Okay, hope to see you there. Thank you guys. Have a good one.